Good day, everyone, and welcome back to my YouTube channel. Today, I want us to cover one of the most controversial, longest topic in math, which is Euclidean geometry. And in this video, we'll obviously be covering introduction to Euclidean geometry. So the objective of this video is obviously to give you a reminder of what you've already learned. If you haven't already learned it, this is the perfect platform or perfect time for you to get introduction to those topics. But the topics that I really want us to cover in this video are supplementary angles, triangles, and parallel lines. So without wasting any further time, let's get straight to the video. Okay, so the first part of the video, I want us to talk about supplementary angles, the topic of supplementary angles. And what do we mean by supplementary angles? Basically, what we mean by supplementary angle is that if we have some kind of a shape, or let's say, for example, we have a straight line, actually, not even a shape, a straight line. So let's say we have a straight line, and this straight line forms a bunch of angles, right? It forms a bunch of angles, and here you're told maybe that this angle is 60 degrees, this one is 50 degrees, this one is 30, and they want you to calculate the value of this one, and they'll label it X for that matter. Basically, the concept of supplementary angles is that all angles on a straight line add up to 180 degrees, and that's basically what supplementary means. It means that if we add all these angles together, we have to get 180 degrees. And obviously, knowing that now, we can turn this into an equation where we say X, which is the unknown that we're trying to find, plus 30 plus 60 plus 50 have to add up to 180 degrees. And with Euclidean geometry, every single time we make a statement like this, or we come up with an equation like this, we always have to give reason. There's a mark for reason initially, obviously. So that reason would be angles on a straight line. On a straight line. Straight line. So that would be a reason, okay? So we're saying angles on a straight line add up to 180 degrees, or angles on a straight line are supplementary. And from that, we can just add up all the angles. So we know that 30 plus 60 will give us 90, and plus 50 will give us 140, okay? Which equals to 180 degrees. And obviously from here, we can just transpose the 140, and if we transpose it, that will give us my 180 minus 140, which gives us 40 degrees. So the value of X in this case is 40 degrees, okay? So that's the concept of supplementary, okay? It applies on a straight line. So if we have a straight line and we're given an X amount of angles, or we're given these angles right here, and we just have to find the unknown. In our case, it was X. We can just use the theory of supplementary to kind of finalize or find the value of the unknown, and in this case we managed to find that it is 40. So supplementary doesn't only apply to angles on a straight line. It applies to triangles as well, okay? So let's say, for example, we're given a right angle triangle like this, and we're told, obviously, with a right angle triangle, we're not even told it's something you should know, that that's 90 degrees, and we're also given the value of 40 here. Okay, from that you can find the value of this angle. Let's label it X as well. So from that, you're able to find the value of that angle. There's many methods obviously we can use in order to find that angle, if obviously you're in grade 10, 11, or 12, since you've learned different methods in those grades. But if you haven't, the best or the simplest way in order to find the value of X is to say that X plus 90 being this angle right here, and plus 40 are also supplementary, so they add up to 180 degrees. And obviously the reason will be different because this is not angles on a straight line. Your reason for this will be angles on a, or in a triangle. Okay, so obviously you're gonna write that down in words. You're gonna say are supplementary. I'm just summarizing because I don't have enough space, but basically what our theory here is that angles of a triangle add up to 180 degrees, or angles on a triangle are supplementary, if you can put it like that. And here as well, we'll just say 90 plus 40, which gives us obviously 130, so that will be x plus 130 equal to 180. And in the next step, we're just going to transpose the 130 to the other side, and if we do that, we have 180 minus 130, which gives us 50 degrees. So the value of x is 50 degrees. Okay, so now we know that supplementary can be applied on a straight line. It can be applied on triangles as well. So that's the concept of supplementary angles. Okay, so the next topic that I want to talk about is parallel lines. Parallel lines. Okay, and with parallel lines, there's this word, if I can put it like that, this word, it's called fun. Fun. Everyone likes having fun. Okay, so it's called fun, and the concept here is that we're dealing with parallel lines. Remember, parallel lines are two lines that can never touch each other. Okay, they have the same gradient. That's a factor about parallel lines, so they never really touch each other. They kind of are how do I put it, they're kind of like the same line, so they kind of have the same gradient. If you understand the concept of gradient, you'll know what I mean when I say parallel lines. So in this case, with this concept of fun, we need to be able to identify the parallel lines. And in this case, we assume that the parallel lines are these, and here it will be this, and here it will be these two lines. Okay, and with this, there's a couple of things we can deduce. Okay, so the first part is the f. So what we're saying with this f is that if we do have parallel lines in this f, this angle and this angle will be equal. Okay, and the reason for that is because we say they are corresponding. So this angle, if I can label it angle A, and this angle B, so angle A and angle B are equal, and the reason for that is because they are corresponding. So we can only assume that if obviously those two lines are parallel. If they're not parallel, then those angles are not corresponding. And obviously the vice versa of that would be if we have two corresponding angles A and B, then we can assume that those two lines are parallel. Okay, so with U, it's different from corresponding. With U, what we basically need to assume is that this angle and this angle right here are supplementary. They are supplementary. And the reason for that is because they are co-interior angles. Okay, so if we have two parallel lines like this, and obviously we have the shape which is a U, and we have two angles which are basically not equal, we can assume that the addition, or if you add those two angles, we're gonna get supplementary angles, or we're gonna get the value of 180. So in this case, let's say this was A and this was B, this was angle B, so we're gonna assume that angle A plus angle B are equal to 180 degrees, and your reason would obviously be co-interior angles. Okay, so the last part of it is the N. Okay, so with this one, we say this angle and this angle are alternating angles. And basically we presume that obviously those two angles, if we call them A as well and B, A is equal to B. Okay, so if we have a shape like N or Z, if you can put it like that, we assume, and obviously that shape is formed by two parallel lines like this. We can assume that the value of this angle and this angle, if they are equal, they're basically equal, and we say they're alternating. So if you were given a shape like this and you deduce that A is equals to B, your reason would be alternating angles. So you'd say alternating angles, okay? And obviously you'd have to give that these two lines are parallel. So if, let's say for example, we were calling these lines E and F and G and H, you'd say EF parallel to GH, okay? So yeah, so those are the three concepts that I really want us to talk about when it comes to parallel lines, okay? So it's fun, and we assume that if we have an F, we have corresponding angles if obviously the two lines are parallel. If we have a shape U, we have co-interior angles, meaning that they are supplementary. And obviously if we have an N or a Z and we have two parallel lines, we assume that those two angles are alternating, or rather they are equal angles. Okay, so the last part of it doesn't have anything to do with parallel lines nor supplementary angles, but it's normally included with fun. So it's something that you're obviously going to learn in your lower grades. It's a vertically opposite angles. So in this case, we have a shape like an X, right? So what we're basically saying with this shape is that this angle right here will be equal to this angle, okay? So if you call that angle A, and that one will be angle B, so we're saying A will be equal to B, okay? Let me just write my B nicely. A will be equal to B, and your reason for that is vertically or vertically opposite angles. Okay, I'm not going to write my angles, I'm just going to show the angle sign. So we assume that those two lines are vertically opposite, okay? And if they are vertically opposite, that means they're basically equal. And we can also deduce that these two as well, they're vertically opposite, so we'll call that C and D. And obviously C and D will also be equal. C and D will also be equal. And the reason for that is the same as the one at the top, okay? But that's not the only thing that we need to deduce about this line, okay? So if you pay attention, all these angles start at the point, and this point is obviously the point at the center. So another concept that we need to know with this is that if we add A plus B plus C plus D will give us 360 degrees. And the reason for that is that these are angles at a point. So they are angles at a point, and they go around, basically. They go around 360 degrees, okay? So angles at a point, if you add them together, they will give you 360 degrees. So if here in this case, you're obviously given the value of A, and let's assume maybe the value of A is 70, and you're also given the value of B, and you're told that it is, let's assume, actually, let's make it a bit more difficult, and let's say we were given the value of A. You're only given the value of A, you're told that it's 70, you're not given the value of C, D, or B, okay? So the first deduction that we're gonna make is, obviously we know that A is equal to B, and if A is 70, that means B as well will be 70, okay? And the reason for that is vertically opposite angles. So it would be vertically opposite angles, okay? So what else do we know? We know that C is equal to D, okay? And just to make it easier, let's allocate a variable for both these values and say that C is equals to B is equals to D is equal to X, obviously. And the reason for that as well is vertically opposite angles, okay? So it's vertically opposite angles. Okay, so now we know that C is equals to D, Okay, so we can agree that C plus D is the same as X plus X, since each are X. So C plus D is the same as 2X in this case. Okay, so if we go back to our initial sum or initial theory, which says angles at a point equal to 360 degrees, we added A plus B plus C plus D, and we say they're equal to 360 degrees. And our reason for that is that they are angles at a point. They're angles at a point. Okay, they are angles at a point, and we have already deduced the value of A, and in this case, we're actually given the value of A, and we're given that it's 70. We have also deduced that A is equal to B because of vertically opposite, so that will also be 70. And we don't know what the value of C is, but we said it was X, and obviously the value of D as well is X, and that obviously equals to 360 degrees. So from here, we can add these two values, and if we add them together, we're going to get 140. And if we add X and X together, we also get 2X, which is equal to 360 degrees. Okay, so now we can transpose the 140 to the other side, and we have 2X on the left hand side is equal to 360 minus 140. Okay, and if we subtract those two, we're going to get the value of 220. So 2x is equals to 220, and obviously to find the value of x, we need to divide both sides by 2, and the value of x in this case would be 110. Okay, so now that we found the value of x, we can substitute it back, and we know that C is equal to D, it's equal to x, and obviously x is equal to 110. So we're able to find the value of C and D using this theory of angles at a point. So that's another question that you can find. You can just be given one value. In this case, it was 70, and you can be able to come up with all these steps in order to solve the value of all the other three sides. Okay, so that's some of the questions that you can get obviously in lower grades, but yeah, this was an example of how you can use that method to kind of calculate the values. Okay, so just to also give you another example of a question related to parallel angles. So you can be given two lines that are obviously parallel like this, and you're given a line or a diagonal line that goes through those two triangles, or those two, sorry, not those two triangles, those two parallel lines. And here you're told that that's A, that's B, that's C, that's D, and here it is E and F. Okay, and obviously that value here, or this one, is G, and this is sorry, that's not G, that's H, and that's G. Okay, so you're given something like this, and now you have to label all these, or you have to find the other pair of this angle, or you need to find another angle that's equal to this one here. Okay, so obviously they would have told you that these two lines are parallel, so you need to start looking at those fun shapes that that we spoke about. So the first thing, if you see, is we have a shape which is kind of like a Z. So we have this shape here, which is like a Z. Okay, so, and we know that if we have a shape like that, those two angles are alternating, so they're equal. So that's a pair that I was able to find just by knowing that those lines are parallel. So we have alternating, we were able to find that. And here, another value that we're able to find is this angle and this angle. Okay, and those two are corresponding. They're corresponding. If you technically, or you basically assess this shape here, you'll see that it looks like an F. And obviously if we have a shape like an F, we have corresponding angles. And last but not least, another one that we spoke about was obviously what's this? Co-interior, and we can deduce that this one and this angle, if we add them together, they're gonna be supplementary. And the reason for that is because we have co-interior angles. So we're not basically doing a question. I just wanted to give you a feel of how those three shapes can come up in one thing. You know, they don't have to be separate at all times. They can be included in one concept or one thing. So you being able to identify that obviously takes time, but every single time you hear of the word parallel lines, those are the three things that you need to pay attention to. Obviously, we have alternating, we have corresponding, we have alternating, we have corresponding right here, and obviously we also have co-interior angles. So that's basically something that I want you to pay attention to or look up to every single time you see parallel lines. Okay, so the last, or actually not the last topic, but another topic that I really want us to talk about is the concept of similarity. Okay, and what basically that means. Okay, so let's say, for example, we're given two triangles. Okay, so let's say we have this triangle over here, and we have another triangle over here, a bigger one, just like that. Okay, so let's call this triangle ABC, and we're obviously going to call this one E. Sorry, not E. We're going to call it D, E, and F. Okay, so let's say we have these triangles over here. So with similarity, we're basically saying that if this angle is equal to this angle, and this angle right here is equal to this angle, and obviously the last one, automatically they have to be equal. This angle is equal to this angle. We assume that these two triangles over here are similar. Okay, they're similar. So they basically how can I put it? It's like a mini, they're basically different in terms of their scale of which one is bigger, but in terms of their structure and angles and everything else, they're all equal. Okay, so here obviously we have A. If we can deduce that A is equal to D, and we can also deduce that B is equal to E, and F is equal to C, or C is equals to F, then we can say triangle ABC is similar. So the sign for similar is these three bars, is similar to triangle DEF. Okay, so that concept of similarity comes about if we know that the interior part or the angles of those triangles are equal. Okay, so that's one topic we're obviously going to dive into as time goes, but because there's a lot that we can deduce, and there's so many calculations that we can do with just similarity, but in this video is just an introduction of what similarity means. Basically, it's that the two triangles have equal angles. Basically, they have equal angles that are kind of like corresponding. So A is equal to D, B is equals to E, and obviously C is equals to F in this case. Okay, so that's just what I wanted to touch when it comes to similarity. But yeah, it's such a big topic that we're going to speak about in the upcoming videos. But for now, that's the only thing that I want you to know when it comes to similarity. Okay, so the last topic that I really want us to talk about still is part of the triangles, and that's the topic of congruency. Okay, so what do we mean when we say triangles are congruent, or objects are congruent? What we're basically deducing from congruency, or what we basically mean by that, is that we have two shapes that are exactly the same. We have two shapes that are exactly the same. So you need to always give out reasons as to why those shapes are congruent, or those triangles in this case are congruent. And we have 4 kind of reasons that I will like us obviously to talk about. But the first reason is if, let's say, for example, we have 2 triangles. Let's say we have this triangle here, and we have another triangle here. Okay. We have another triangle like this, and let's call that triangle PQR, and we're going to call that STU. Okay, and it is given that this side PQ is equal to ST, and also given that PR is equal to SU, and last but not least, QR is equal to TU. Okay, so it is given that PQ is equal to SR, and obviously you need to give a reason every single time you come with that deduction, and in this case it's given, and it's also given that PR is equal to SU, and also the reason for that is given, and last but not least, QR is equal to TU, and the reason as well it's given. Okay, so now from that we can deduce that triangle PQR is congruent to triangle STU. Okay, so I want you to pay attention to something. You see, from here I move from P all the way to Q and then R, and as well with the other triangle I move from S to T to U. I moved in the same pattern, so that's very important. That's something you need to keep in mind. Okay, so I need you to keep in mind that these 2 triangles are congruent. So STU is congruent to PQR, meaning that they're basically the same, or they're equal. Okay, so from that you can now deduce that this angle here is equal to that one, and that one is equal to that one, and last but not least, this one will be equal to this one as well. So that's the first concept of congruency, which means side, side, side. So if we have 3 sides that are equal to the other 3 sides of the triangle, then we can assume that those 2 triangles are congruent. So side, side, side. So keep that in mind. So the next way we can justify congruency is if we have 2 triangles. Okay, 2 triangles. Let's say this is the second triangle, and let's say we call that UVW, and we call the other one XYZ. Okay, so let's say, for example, we have a concept like this, and we are given that this angle U is equal to angle X, and we're also given that angle V is equal to angle Y, and the last thing that they give us is that YZ is equal to VW. So in this case we have 2 angles that are equal, and we have a side. Okay, so now we know that UV is equal, oh sorry, not UV, I made a mistake. We know that VW is equal to YZ. We know that angle U is equal to angles X in this case, and we also know that angle V is equal to angle Y. Okay, so all those concepts are given. You're not allowed to do this. You're supposed to say given for every reason that you give, but I'm just trying to summarize and not waste too much time. So you know that all those are given, then you can basically assume that triangle UVW is congruent to triangle X, Y, Z. Okay, as you see as well here, I went from U to V to W. As well here, I have to go from X, Y, Z. So I basically need to use the same pattern to kind of keep the flow. It's only right I do so. If I can't do that, then I probably messed something up. So the reason for this congruency here is angle, angle, and a side. Okay, so if I can write that down in a more neater way, or in a neat way, it's angle, angle, side. So that's the second reason that I wanted to give for congruency, or that you can give for basically congruency. So if you have two triangles that have two equal angles, then and one equal side, you can assume that those two triangles are congruent. And obviously from here you can also deduce that this other angles are equal, because if you have a triangle and angle U is obviously equal to angle X and V is equals to angle Y, then automatically angle W has to be equal to angle Z. Okay, but that doesn't tell you congruency. Obviously I told you with angles being equal, the sides don't have to be equal. We can assume that they are similar. The sizes can be different, but all angles can be equal. Okay, so if we have all angles of a triangle, of two triangles being equal, we say that is similarity. Okay, we're not saying basically the two triangles are equal in terms of size. We're just saying the shape of them is the same. But with congruency, we're deducing that everything about those two triangles are the same. Okay, so if you have two angles that are equal and one side, then we can assume congruency. But if we only have three angles and no sides that are equal, then we can't assume that those two triangles are congruent. We can only assume that they are similar. But if we're given two sides and two angles and a side, then we can say that those two triangles are congruent. And obviously our sign for congruency is these three bars right here. Okay, so another way we can deduce congruency is if we're given, let's say, another triangle, let's say a triangle like this, and we're told that that's F, G, H, and we're given another triangle, and we're told that's I, J, and K. Okay, so if we're given these two triangles and we're told that GH is equal to JK, and we're also given that FH is equal to IK, and then we're also given that this angle right here is equal to this angle, then we can assume that those two triangles are congruent. But you need to keep in mind the angle that is equal to the other triangle is an angle that's in between the two sides. Okay, so it's not just any random angle, it's an angle that's between the two sides. So let's say, for example, in this case, we said the angle was G. Then the angles that are equal are G and J. Then those two triangles wouldn't be congruent. If the angles that were equal with G and J, they wouldn't be congruent. Only if the angle that's equal to the other triangle is the angle in between the two lines that we're given that are equal. Okay, so to basically write that down, I would say side FH is equal to IK, and here we know that GH is equal to JK, and we know that angle H is equal to angle K, and that's the included angle, meaning the angle between the two sides. And all this information obviously is given. All this information is given. Then we can assume that triangle FGH is congruent to triangle IJK. triangle IJK, and the reason for that is side, angle, side. And you see that the angle is in the middle of the two sides, meaning it's in between, it's the included angle. So we can assume that these triangles are congruent, or they're basically the same in terms of everything, size and everything else. Okay, so obviously as I don't draw them according to scale, so you might see that one is bigger than the other, but basically with congruency we assume that they are the same size and the same everything. Okay, so the last thing, or the last way we can kind of determine congruency in this case is if, let's say, we have one triangle, and obviously we assume that that's 90 degrees, or we're given that that's 90 degrees, and we have another triangle and we're also told that that's 90 degrees, and let's say this is A, B, C, and that's D, E, F, and we're told that BC is equals to EF, and DF is equal to AC in this case. Obviously that's the hypotenuse. Okay, so if we have this right here, where angle B is equal to angle E, and obviously both of them are 90 degrees, and the reason for that is because it's given. And we also have AC, which is the hypotenuse, equal to DF, and that's given. Remember, these are the hypotenuse. And we have BC, which is equal to, in this case, EF, and obviously that's given. Then we can assume that the two triangles are congruent. So triangle ABC is congruent to triangle DEF. And your reason for that is we have a right angle, the right angle, which is obviously the 90 degrees. We have the hypotenuse, which is obviously this one, which is the angle opposite to the 90 degrees. The hypotenuse is always the one that's opposite to the 90 degrees. And we have a side. We have a side that are equal. Then we can say that these two triangles are okay. So that's basically it when it comes to congruency. The first thingy is obviously the first theory is obviously if we have three equal sides, we can assume that the triangles are congruent. If we have angle side, we can assume that they're congruent. If we have side side, we can assume that they're congruent. And last but not least, if we have a right angle, meaning 90 degrees, the hypotenuse being equal and another side being equal, then we can assume that those two triangles are congruent. So this here is basically a revision of Euclidean geometry, and I'm going to need you to obviously go study it, remember it, do a couple of questions before it, before we can tackle the big part of Euclidean geometry. In the next video, I will be giving you another way of, not even another way, I'll be giving you a revision on another topic, which is obviously the properties of quadrilaterals, which is very helpful when it comes to Euclidean geometry, because knowing those properties can help you find certain angles. Okay, so in the next video we'll be talking about that concept of properties of quadrilaterals, and hopefully that can help you in obviously tackling the bigger picture, which is the theories of Euclidean geometry. So that is it from my side. I hope you enjoyed the video. I hope you go through the video over and over again until you get these concepts right, if there's any misconceptions. But yeah, that's it from my side. If you're new to the channel, please like, share, and subscribe. Tell your friends about it. This is free content that can help you a lot, obviously, with your future. If you're a returning subscriber, just comment on a certain thing that I might have mentioned or said that you didn't understand, and I can communicate with you via the comment, or you can join our metric WhatsApp group chat. The link will be in the bio or in the description, and yeah, you'll get to see different questions there. And yeah, you can join our free lessons as well, which are on weekends. But yeah, that's it from my side. Please share, like, and subscribe. Cheers.